So welcome to the first lecture on discrete probability distributions. So in this lecture we will discuss the introduction to probability distributions. We will discuss random variables, probability mass function, expected value and cumulative distribution function, and finally end with permutations and combinations. So let's start with introduction. So what is a probability distribution? So in general, before we discuss probability distribution, let's discuss random variables first. So what are random variables? So a random variable is a function that assigns numerical values to different events in a sample space. So for example, let's say I have a sample space. So this is the sample space and these are all the events that are in sample space. Let's call it E1, E2, E3, E4, E5. So random variable here is considered as x. For example, there is a random variable x. So here the function of x is the probability of each of these individual events in the sample space. So writing as it as a set of these events is what we call a random variable. So in chapter 3 we discussed very specific details about the outcomes of different diseases, but here we have to give it some probability from giving probable structure. So giving it a structure is what we call a random variable. So in terms of random variables, there are two types. So number one is a discrete random variable. Number two is a continuous random variable. So for one is a discrete random variable, second is a continuous random variable. So the name itself says in each of these values. So what is a discrete random variable? So a discrete random variable is a function So a discrete random variable is one for which there exists a discrete number of numerical values. So we call that a discrete random variable. For example, let's say we have an event where we are throwing heads and tails on a coin toss. So in a coin toss there are only two events that are probably there, the probability of a head and the probability of a tail. So each of it is half. So if I name this as event and probability, event is head 1 by 2, event is tail 1 by 2, and write it as a table. So the function that represents this table is a discrete random variable because there is a limit to the number of events that are possible in this random variable. So that's why we call this a discrete random variable. So the other one is a continuous random variable. So a continuous random variable is whose variables, whose possible values cannot be enumerated. So an example of this to look like, for example, you can take the example of, So you can take the example of, say, your blood pressure. So blood pressure is a random variable which is generally continuous because you can continue to enumerate the values, but there is no end. So there is no end point, or then there is no last event in this. So because there is no end point, so that's the reason why blood pressure can be considered as a continuous random variable. In the same way, you can consider heart rate as a continuous random variable. If you are thinking about long time, and if you are thinking about a short amount of time with a finite number of events, then blood pressure is not a variable that you want to consider, because that variable can change continuously and will never be at one single point at any given point of time. So that is the idea behind a continuous random variable. So in this lecture, we'll discuss only discrete random variables. So with that, let's start the first topic, probability mass function, or PMF, of a discrete random variable. So I'm going to write RV as the short form for random variable. So what is a probability mass function? So a probability mass function is basically a mathematical relationship So it can be a mathematical relationship or a rule, so which assigns any possible value R of a discrete random variable. So the probability P of x equal to R. So this is the idea behind the probability mass function. Is a function that assigns any event a given probability. So this assignment has to be always a positive probability, and the other name for probability, so the other name for probability mass function is probability distribution. So remember that we are making a distribution involving probabilities. So that's the idea behind discrete random variables. So for example, let's say I have an example of a probability mass function for hypertension control. So this is the probability of how many episodes a given or how many patients in a given drug trial have hypertension due to the drug. So for example, the number of patients with 0 events, so the number of people with 0 events is 0.008. The number of people with 1 event is 0.076, with 2 events is 0.265, 3 events is 0.411, 4 events is 0.240. So this is a probability mass function. So how do you create the probability mass function table? Let's take a simple example of a general probability distribution. So let's for example say that this is a table that shows the number of assistance programs utilized by families with children in Head Start programs in Southern Ohio. Now, how do you draw the probability mass function from this? So how would you draw the probability mass function from this? Is note down the number of programs, and in this one let's write probability. So for each of these events we want to know what would be the probability. So the number of programs here represents the event, right? So in this the event here is 1, 2, 3, 4, 5, 6, 7 and 8. In each of them you have a frequency. So in this frequency you want to know the probability is divide each frequency by the total value that gives you the probability. So the first one will become 62 over 297. The second one will become 47 over 297. third one will become 39 over 297, fourth one will become 39 over 297, fifth one is 58 over 297, sixth one is 37 over 297, 4 over 297 and 11 over 297. So this is the idea behind. So this is the idea behind how to calculate from a given table. How do you calculate the probability mass function? So all the probabilities, when you find the actual value of these probabilities, that gives you the example of probability distribution. So if you calculate the values, you should get a value of 0.2088, 0.1582, 0.1313, 0.1953, 0.1246, 0.135, so last one is 0.370. So this is the idea of how to draw a probability distribution table. So this is how you can draw the probability distribution or probability mass function. Now, what are the properties of discrete distribution? So properties of a discrete probability distribution. So what are the properties of it? So the first property is the sum of probabilities is always equal to 1. So the sum of the probability of each individual event will be equal to 1. Second, all of the probabilities, so the probability value, each individual value lies between 0 and 1. So these are the two main properties of a discrete probability distribution. How would you know if this is true? Is, for example, you can try summing up all the probabilities that you have here. For example, all these probabilities, which is 0.0008 plus 0.076 plus 0.265 plus 0.411 plus 0.240 will be equal to 1. So this is the sum of probability of x equal to r. So is always equal to 1. And also notice that each of the individual probabilities is always between 0 and 1. So this both are true for a probability distribution. So this is the idea of how you can look at a probability distribution. Now this brings us to the question, the next one. Let's take a simple, the next one is the expected value. So let's take the first example that we took. So in this example, how would you calculate the mean of the data? How would you calculate the mean of the data? So to calculate the mean is basically finding the expected value. So the expected value of a discrete random variable is equal to the mean of the distribution. So we represent expected value as expected value of the random variable x is equal to mu. So mu here represents the mean. So the expected value here can be written as sigma I equal to 1 to r xi into xi times the probability of xi, x equal to xi. So this is the formula for expected value. So for the example that we have here, how would you calculate the expected value? So remember that the formula for expected value is sigma I equal to 1 to r xi times probability of x equal to xi. So it's basically multiplying the variable with its probability and adding them up. So in this, the variable, the first one is 0. So 0 times the probability of that variable is 0.0008 plus next variable times the probability 1 times 0.076 plus 2 times 0.265 plus 3 times 0.411 plus 4 times 0.240. So this is the expected value that we have here. So if you sum it up, you should get a value of 2.80. So 2.80 mu. So here what does the 2.80 actually represent? So it actually represents the average number of episodes, average number of patients with hypertension. It does not show you the average probability, but it actually shows you the average number of patients that are going to end up having hypertension. With the probability distribution, an average of at least 2.80 number of patients will end up having hypertension during the drug trial. So you will have at least 2.8 hypertensives for every 4 of them that you have treated. So this is how you can calculate the value. So let's take another example. So let me give you another example so that you can do this on your own. So this is the probability mass function for the number of episodes of otitis media. So otitis media in the first 2 years of life. So this is the probability mass function of otitis media. So if you don't know the meaning of otitis media, so otitis media is a disease otitis media is a disease of the middle ear. So middle ear is one of the common diseases that you end up going to the doctor for. So an example, so this is a common example of understanding discrete random variables. So use the data below now and try to calculate. So first question is check if the distribution is complete. How would you check the distribution is complete? So calculate the sum of probabilities is equal to 1 or not. Second, calculate the expected value or the mean. So both of them are mean the same. So the formula is sigma x times probability of x equal to r. So remember that, add the value into probability plus again add the value into probability. This way continuously add the values and finally find the probability that you end up with. So pause the video right here and try to solve this problem. So if you are done with that problem, try another one. So try this problem. So this is the one that we already did before while we calculated the probability distribution. So this is the probability distribution function. So first thing, again, check if the distribution is complete. So how would you do that? Calculate the probability is equal to 1. So it's already given 1. So you don't need to do it again. So now the second thing is calculate the expected value or the mean of the distribution. So pause the video right here and try to solve this problem. So next, let's calculate the variance. So variance of a discrete random variable. So the variance we already know is represented by sigma square. It's also represented by VAR of x. So variance of the random variable x is given by sigma I equal to 1 to r xi minus mu whole square times the probability of x equal to xi. So this is the idea behind the discrete random variables variance. You can also write it in the short form as E of x minus mu whole square. So when you write this, you can also write this as a short formula as E of x square minus mu square. So which basically means sigma I equal to 1 to r xi square into probability of x equal to xi minus mu square. So this is the formula for sigma square. Right. So let's take the example of the otitis media example and try to calculate the variance of that problem. So this is the problem that we saw before for the otitis media. So if you calculate the expected value E of x, which is also equal to mu, you would have gotten a value of 2.038. So when you want to find sigma square, so sigma square is E of x square minus mu square. So E of x square can be written as sigma I equal to 1 to r xi square into probability of x equal to xi minus mu square. So we already know the value of mu from the previous problem. Now we want to know this value. How would you calculate this value? So for this, let's take a small table. So let's construct a small table. So this is the first value is r, probability of x equal to r and r square. In the next one we have r square times probability of x equal to r. Remember the x square into probability of x, so xi square into probability of x equal to xi. So this is the value that you are using here. So r is 0, 1, 2, 3, 4, 5 and 6. The probability is 0.129, 0.264, 0.271, 0.185, 0.095, 0.039 and 0.017. R square is square of R values is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36. Now multiply these two values, right? Probability this way, this column and this column, each individual value. So 0 into 0.129, you end up with 0. So the next value is 1 times 0.264. So the same value 0.264. Next is 4 times 0.271. That gives you 1.084. Next is 9 times 0.185, so that becomes 1.665. Next is 16 times 0.095, that value is 1.52, and 25 times 0.039, that value is 0.975, and 36 times 0.017, so that gives you 0.612. So when you add it all up, you should get a value. So next one, add all of these values one by one, so the sum gives you 6.12. So this value is sigma r square into probability of x equal to r is 6.12. So when you want to calculate sigma square, we know the formula is sigma I equal to 1 to r xi square into probability of x equal to xi, but here xi is given as r, so we can replace the formula into r square ri square into probability of x equal to ri minus mu square. So this entire value is given as 6.12 minus mu is 2.038 square. So that gives you a value of 1.967. So sigma square is 1.967. So if you want to find the standard deviation, of the discrete random variable, so we can write it as, so SD of x can be written as square root of the variable variance of x. So the square variance of x value is 1.967. So square root of 1.967 gives you 1.402. So the standard deviation of x is given as 1.402 and the variance of x is 1.967. So this is how you can calculate the values in any given distribution. So this is how you can calculate the values for any given distribution. So with this case in, now take into consideration, so let's try another problem so that you can solve this on your own. So try this problem. For this number 1, you've already calculated the expected value, use that expected value. So number 1, calculate the variance. Number 2, calculate the standard deviation. Right. So calculate the variance and calculate the standard deviation. So pause the video right here and try to solve this problem. So next let's discuss cumulative distribution function. So are also called CDF. So CDF basically is a representation of cumulative distribution function. How would you calculate the cumulative distribution function? Let's take the example of otitis media. So the first example, the second example that we took. So in this, how would you calculate the CDF? So remember that there is a difference between probability mass function and cumulative distribution function. So the word that changes here is the term cumulative. So cumulative, add everything before the event. So what does that mean? It's represented as capital F of x. So how would you take, for example, let's take the same example that we have here and let's try and calculate how would you do the cumulative distribution function. So in this we have, let's take a small table so that it becomes easier to understand. Let's take R, probability of x equal to R, and let's take f of x. So we let's write down the values 0, 1, 2, 3, 4, 5 and 6 and 0.264, 0.271, 0.185 and 0.095. Next you have 0.039. I think I might have missed some values. Sorry. So the first value is 0.129. So the last one is 0.017. How would you calculate the cumulative value? Is for the first event, you generally write down the value for the first event. For the second event, you write down the sum of the probabilities of both the first and the second event. So the second one will become 0.129 plus 0.264. For the second event, you are going to write the sum of all the probabilities that are before it. 0.129 plus 0.264 plus 0.271. Next, for the third event, you are going to write the probabilities of all the events before that. So it will be 129 plus 0.185 plus 0.271, sorry, 0.264 plus 0.271 plus 0.185. Next, for the fourth event, write everything before that. Again, 0.129 plus 0.264 plus 0.271 plus 0.185 plus 0.095. Next, for the fifth one, write everything before that. 0.129 plus 0.264 plus 0.271 plus 0.185 plus 0.095 plus 0.039. Next, last one, write the sum of everything. 0.01, sorry, 0.129 plus 0.264 plus 0.271 plus 0.185 plus 0.095 plus 0.039 plus 0.017. So this here is the cumulative distribution function, or CDF. So we also call this the step function. The step function is basically because when you are doing the second one, we take the sum of the two. When you do the third one, we take the sum of the three. When you do the fourth one, you take the sum of the entire four values. 5 is all the sum of 5 values. This way you are going to write until you end up with the last value. So this is how you write cumulative distribution function. So one way of knowing a cumulative distribution function is to represent this on a graph. So when you write this value and when you want to find the values, so let me write the CDF values of EF of EX. The values are 0.129, 0.393, 0.664, 0.849, 0.944, 0.983 and 1.0. These are the functional values. So when you put it on a graph, so in one scale we are taking the events, and in the second scale we are taking the episodes. So this is the number of episodes. So 0, 1, 2, 3, 4, 5, 6. And on this scale we are taking the probabilities. For example, so we start at 0. So until number 1 comes, so there is no, so this is the point where, for example, let's say this value is 0.129. Next, from there you want to draw the second value. The second value is 0.393. Let's say, for example, it's somewhere here. So it becomes this way up. Next one, let's say this value is 0.664. Next value, let's say 0.849. Let's say 0.944, 0.983 and 1.0 here somewhere. So when you draw the values, you're going to draw the graph like somewhat like this. So this is the probability distribution function, cumulative distribution function for the OT test media. So remember that it always points upward. So when you look at it in a graph, so in a graph, a CDF is a stepwise function. So it looks like steps. So that's why it's called as a stepwise function. So it's also a good way to represent a discrete distribution. So a discrete CDF is stepwise, and a continuous CDF is generally a curve. So that's the difference between a continuous function and a discrete function, and this is how you can differentiate these two values. So with that, we end the topic on cumulative distribution functions. Now let me give you some problems to practice. So let's say we have the problem from the first one, so the probability distribution of the food assistance programs. So in this one, try finding the CDF and draw the graph. Right, try to draw the graph. Don't need to draw to exact scale, draw it as a rough picture so that everybody can understand it clearly. So try this as an example. So pause the video right here and try to find the CDF of this function. So this is an example of where it shows the table, the probability distribution of the number of boys in families with 4 children. So here first they are asking you to find the expected value, then find the standard deviation. So first find variance and then find standard deviation, and third also find the CDF. So they have given you it to fractions, so try to convert it into the original values and then try to solve the problem. So pause the video right here and try to solve this problem.